Hi everybody. This is a English voiceover of the part 1 of the restoration of the Braun TS3. The subtitling, automatic subtitling in YouTube proved to be totally catastrophic. That's why we did the part number 2 in manual, typed it in and subtitled it in English, but this took us about 8 hours of our time, which was absolutely ridiculous. So I'm just doing the part number 1 as a voiceover. And this radio here is the Braun TS3, 1957, in a reasonable condition, apart from that it seems to have come from a smoker's estate, maybe the Marlboro Man, who knows. Right, so let's get down to opening it up and having a look what's inside. It's sort of some nicotine stained on the front. I wonder, what the back's gonna look like. But well, nothing but hope. See, open it up, check it out. The only thing that worries me a bit is somebody cut off the power cord. Who knows? Maybe something went wrong there. Oh, all right. Well, it looks a bit dusty, but very much complete. Oh, yeah, very dusty. Look at those balls of dust underneath a chassis. But, well, it's okay. Worthy of a restoration. EL95 push-pull output stage. This is the mono version, right? That had the push-pull. First thing I should say here would be to do some cleaning with compressed air. And take it outside, give it a good blasting over. Right on. I've just parked it outside on some wheelie bins, blowing it out. There's a lot of dust coming out of there. When blowing out those things with compressed air, take care not to blow directly on the coils, so as not to break the wires. But looking at it here, well, that was a vast improvement. Now I've put it on the table inside, and I'm just sort of trying to clean off the all these nicotine stains, and so I'm rubbing it with a special sponge. It's called dirt eraser. I don't know whether it's known outside of Germany, but it's basically a sponge which has a little sort of needles which break off, and they would go into the grain of the wood, for example, and take out all the dirt and grime, which you can clearly see on the sponge. That material's made by BASF, but probably it's not available outside of Germany, so not worth further mentioning here. So anyway, I've got it cleaned up, and when looking at it in a sort of a moist state, the wood on top is still moist. You can see that there's definitely potential to get the casing done well, without repainting it or anything like that, just by some proper carnauba wax, polishing it up and sorting. So I'm not going to do any sanding down and repainting or relacquering or anything like that. I'm going to keep it like this because it's in such good condition. Right. So now I've removed the bottom inspection hatch and discovered the Braun people, they were so friendly and nice as to provide us with a complete schematic of the receiver on the bottom, and I have an excellent copy machine, so I just scaled it up, copied it, and now we're ready to roll. Right, and looking at it, it's sort of very, very good to work at because there's a lot of space. And what I'm going to do now is just do the basic capacitor changes which need to be done. And I'm going to give it a test run, you know, right away and see how well it works. Right, so, okay, I'll just do a quick dim bulb test and see how it actually behaves, see what happens. The dim bulb test is just to check out whether the capacitors will let themselves get reformed or whether they are total goner, meaning that they are short-circuited. The radio is in line with the light bulb, 25 watts, and now I'm sort of charging those capacitors inside with only a fraction of their actual voltage, which they are supposed to run at later. And you can see that the bulb sort of is getting dimmer and dimmer. This means the capacitors seem to be reforming. And watching this, of course, if the light bulb stays bright all the time, then you might as well forget it. Then there's a dead short somewhere, and it's not worth sort of doing any further testing or reforming or anything like that. Then you might as well just get down and recap the whole thing. So the light bulb's not that bright, and I've let it run now for like about 30 minutes. Next one, after the 25 watt, comes the 40 watt. This will increase the voltage which is applied to the main smoothing capacitors. And you can see they have already reformed quite a bit. The bulb's not as bright anymore. The aim of the whole thing is to basically reform those capacitors which are in the power supply. And this will be those ones about, you know, after the bridge rectifier, the ones I'm pointing to right now. It's 2 times 50 microfarads, normally on European radios. And it's very, very advisable to do this, to really just do the dim bulb test, reform them before you blow the bridge rectifier or maybe even burn out the transformer, which would be a great shame. You know, sometimes, you know, blowing out the transformer is basically the death sentence for a radio because you can't get another one. So anyway, the 40 watt bulb is not glowing brightly anymore, which means now I can sort of go over, do another one, 60 watts. That's the next plan. Once the 60 watt bulb is in, then I can check voltages, especially the voltages on the grids of the output pentodes, the ones in the push-pull stage. If any voltage above 0 is on the grid, that means the coupling capacitor from the phase inverter, excuse me, is defective, especially the top one. The bottom one is close to ground, and that's not so much of a problem. But the top one from the anode of the phase inverter will be the one that's to watch out for. So now I've got the setup here. The voltmeter. I'm measuring voltage on the grid of the top pentode. That's where the anode, 170 volts from the phase inverter comes to. And of course, this valve is the one which is the one in danger, always. So I'm going to do a measurement here. So I put in the light bulb. Of course, there's no rectifier tube, so right away we have voltage on the grid of the top pentode. Now the valve, becomes conductive and the voltage decreases. But take note, we had 17 something volts on it right at the beginning, which means that that capacitor is leaky. Right, now we have plus 3.4 volts. Still too much. So this is no good. So before I go any further with getting this the set back up and running, I'm going to have to replace that capacitor, the one between the anode of the inverter stage, phase inverter, and the grid of the top pentode. And the problem here being is that if the voltage on the grid of the pentode is in the positive range, it means that valve is very, very conductive, and that can damage the valve. It can also cause the output transformer to burn out. Right, so I'll just go about changing that capacitor, which goes from the anode of the phase inverter to the grid of the top pentode. For starters, I'm going to put I have put my little slim flashlight in there. Of course, naturally, Murphy's Law, it's in the most, terrible place to get to of the whole radio. That's that capacitor. It sort of motivates you, for starters, but has to be done before we continue any further. So there's me fiddling around with the side cutters, smallest side cutters you can get hold of. I'm trying to snip it out, and then, like a surgeon, try to get the new one in. But we will succeed. Yeah, and with myself faffing away there, with my minute soldering iron and everything, it's a comforting thing to know that doing this capacitor, the most difficult one in the whole radio, is me having done the most unpleasant task at first. It can only get better. It can only improve. Yeah. So anyway, very, very tight job of getting it in, but it's good that I didn't take the chassis of the radio out of the housing yet, because you can see myself resting my hands, both of them, on the bottom, wood ledge, and that makes it a lot easier to do the job there through the inspection hatch. Yeah, and at this point, I'd like to say it's a big blessing to have one of those small SMD type soldering irons to work on a radio chassis like that, because it enables you often to just get by and solder or desolder a component lying beneath another one without you having to snip it away. And this is what I'm doing here, sort of wangling my way past the other components with that thin soldering iron. It's just like a pencil. I can recommend it to anybody who has to do with old radios. Get one just for the really difficult and cramped, space-wise cramped tasks. Right, and now, seeing that the capacitor is fitted, we'll do the test once again, measuring the voltage from the grid of the pentode to chassis ground. So not to the cathode of the pentode, to chassis ground. So we will get a voltage close to 0. Right, and now that it's warming up and the tube is beginning to conduct, we can see slight negative bias to the grid. That's how it should be. Yeah, nice. And is sound coming out of the radio? Amazing. That's yeah, I like that. We can now delete the bulb and just go to full mains directly. So I've connected it to 20 volts directly, and it receives you know, pretty reasonably well. Sound is sort of okay. But the thing is, it's you know, when I sweep across the dial on FM, there's not so many stations to be received, although there's a wire in the antenna socket. I'm just going to do some checking out there. Nothing happening on AM. Okay, yeah, a little bit, but just interference. Although there's no decent AM antenna on the radio right now, or connected right now. Well, this, yeah, something has to be done with the reception quality. There's something wrong there. I have to sort that out in a, you know, one way or other. And you know, me looking at the inside of the radio through the inspection hatch leads me to the decision to basically do the other capacitor going to the grid of the second pentode, and you know, all these caps which are in the vicinity of the audio output stage, I'll just do them right now because, you know, seeing as I'm in there, I might as well just do it. What think? Yeah, right? Right, and for putting in the newer components with the short wire ends, I just use the crimp-on sleeves to lengthen the wire ends to solder them in. Helps a lot. Okay, and now comes the next problem. The loudspeaker potentiometer, or the volume pot, it's very, very, very stiff, hard to turn. So I'm going to have to sort of get this thing moving somehow. First of all, just take the knob off, and then the plan is to, first of all, heat the shaft of the potentiometer, or the rheostat, or whatever you may want to call it, with a good soldering iron. Get it hot, because basically the problem there is that the grease, which was once put in the factory, has hardened to such an extent that it's hindering, you know, you rotating the shaft on the inside. And you have to get the old grease soft in such a manner so that you can basically, you know, turn the shaft and also get some light oil, like for example WD-40 or something like that in there to mix with the old grease, or better even, to wash the old grease out completely and replace it with new grease, depending on how well you can get to the whole thing. That's the whole problem. But first of all is to get the shaft moving freely. And this basically can only be done by repeatedly heating it, turning it, applying some more light oil like WD-40 until the shaft is free. So then, you know, you can, for example, blow out the or wash out the old grease with brake clean or some very light oil like petroleum, something to that extent. But anyway, that's what I'm at right now. Okay, so I eventually got the volume control going pretty well, but it took me 4 times of heating and applying WD-40 to get it to actually stay moving, you know, freely. So you know, it mustn't succeed in the first time necessarily. So you remember me sort of saying, yeah, the FM reception wasn't so hot. Well, I've sort of gotten a bit more into this and checking the radio, turning it on FM, like now. Now waiting for it to warm up. And as you can hear nothing, right? Just nothing. So my suspicion was the mixer tube, which in the FM mode is an amplifying stage. And I'm rocking around on the tube. And something should have happened, you know, if the contacts between the tube or the tube pins to the base, or the socket of the tube, rather, will work. But tapping it with a screwdriver will get the radio going, which means that the valve or tube, whichever way we may want to call it, has got an internal short or an internal open. So you have to tap it to make it work. So I have to go off and get some replacement. Now the replacement I got, it's an ECH 83, and many people will ask themselves, oh well, you have an ECH 81 tube in there and you're putting an ECH 83 in, different tube. No, it's not. ECH 83 is exactly the same as an ECH 81, it's just got better specifications. More to that later. So now I'll just quickly fit it. Watch me and then listen. Just let it warm up quickly. Now there's a heck of a lot more stations on FM all of a sudden. So yeah, this one amplifies a lot better than that that tube with shorts and whatever, you know. You just had to bash it to get it going. No, that's okay. Right, and now the difference between the ECH 81 and the ECH 83 is that the ECH 83 is a tube which is especially designated for car radio mixer stages, which have a very, very low anode voltage of around about 12 volts or whatever. And in the production of both tubes, that's one production line, the ones which were, you know, measured with particularly good emission were the ones which were selected out and then stamped as an ECH 83 instead of an ECH 81. So basically, you know, they are cheaper than the ECH 81, and they are the better tube, because they have the better emission. Right, and I'll take a marker pen now and mark all the suspicious-looking capacitors to change them. Now, I went this route to get the radio going first, make it receive properly and so on, before I change all the rest of the capacitors, because sometimes it can happen you do the shotgun method, meaning that you don't even power the radio up and then change all the caps and then start it up for the first time and it doesn't work and you don't know where the mistake is. What did you do wrong? Did it ever work before? You won't know. So always advisable, first get the radio going with a bare minimum of new parts, and then once it's working all right, do the recapping. And it's also advisable to do the recapping in stages, like do about 2 or 3 caps, then turn the radio on, have a look whether it's working still. If it's okay, do the next couple. So thanks for watching and see you in the next video.